Hello viewers, in today's session we are going to discuss another important problem from domain of functions, and in this class we are going to find out the domain of this function f of x, that is equal to cos inverse, and here we have a logarithm of x minus square root of 2 to the base 2 minus half, right? So let us see how we can find out the domain of this function using the concept of principal value branch of inverse cosine function, right? So let us start. So here let us take this term as theta. So we can now take theta is equal to a logarithm of x minus square root of 2 to the base 2 minus half, so that this function it assumes the form cos inverse theta. Now from inverse trigonometric functions we know that cosine inverse theta, it belongs to this closed interval 0 to pi, that is the range of cos inverse theta is from 0 to pi, provided this theta it belongs to this interval minus 1 to 1, that is theta is greater than or equal to minus 1 but less than or equal to plus 1. So let us make use of this inequality, right? So here we have this expression equal to theta. So let us substitute this value of theta in this inequality. So we have now minus 1. Here we have log of uh, x minus root 2 to the base 2 minus half, and here we have 1, that is plus 1, right? So let us solve this inequality. So here we have minus half. So let us add half to this inequality throughout. So we have minus 1 plus half, and here we have log x minus root 2 to the base 2, and here half and minus half get cancelled, and here we have 1 plus half. So minus 1 plus half is minus half, and here we have log x minus root 2, and here we have 2 base 2, and this is 3 over 2, right? So now to move further, here we have log function, that is log of x minus root 2 to the base 2, and here the base 2 is greater than 1, and we know that from the theory of functions, that is the function log of say x to the base a, where this a is greater than 1, then this function is an increasing function, right? So here what we will do, we'll get rid of this log function by raising these three quantities to the power of 2, right? So raising these three quantities to the power of 2, we have 2 raised to minus half, right? And here we have 2 raised to a log of x minus root 2 to the base 2, and here we have 2 raised to 3 over 2. So now let us see this expression. Now this expression is of this form, that is a raised to log of say p to the base a. Then we know that the value of this expression is equal to p. So we have now 2 raised to minus half is 1 over square root of 2, and here we have simply x minus root 2, because the value of a is 2, and the value of p is x minus square root of 2, and here 2 raised to 3 over 2 is 2 root 2, because we can write 2 raised to 3 over 2 as 2 raised to 1 plus half, that is 2 raised to 1, and 2 raised to half, that is 2 root 2. So now we have this inequality. So let us add plus square root of 2. So adding root 2 throughout we have 1 over root 2 plus root 2, and here we have x, simply x, because root 2 and minus root 2 get cancelled, and here we have 2 root 2 plus root 2. So now simplifying this, we have 1 plus 2 over root 2. Here we have x, and here we have 1 root 2. So this is 2 plus 1, 3 root 2, and this is 3 over root 2, and this is x, and here we have 3 root 2. So now here rationalizing the denominator, we have 3 root 2 over 2, and here we have x and 3 root 2. So the domain of this function is given by this inequality, that is x belonging to this interval 3 root 2 over 2 comma 3 root 2, and remember here both the extreme points are also included, right? So the valid values of x for which this function f of x is defined is given by this closed interval 3 root 2 over 2 comma 3 times square root of 2. So this is how, by making use of the concept of inverse trigonometric functions and this inequality, we can easily find out the domain of functions of these kinds. Hello viewers, in today's session we are going to discuss an interesting problem from a domain of functions, and here we have to find out the domain of this function f of x, that is square root of tan inverse 2x minus 1. So here we have to find out all the values, the valid values of x for which this function is defined, right? So here we are again going to use the concept of inverse trigonometric functions, and here we'll see the principal value branch of a tan inverse function, right? So from inverse trigonometric functions we know that tan inverse theta, it belongs to the open interval, that is minus pi by 2 to pi by 2, provided this theta it belongs to the set of real numbers, right? So here theta belongs to the set of real numbers, and tan inverse theta has the range, that is the open interval minus pi by 2 to pi by 2. So here we are going to use this concept to find out the domain of this function. So here we have minus pi by 2, and here we have pi by 2, and between minus pi by 2 and pi by 2 we have 0, right? And here these 2 points are not included. So here we have the square root function. So to start with, this function f of x is defined if this quantity which is inside the square root sign, it has to be greater than or equal to 0, right? Because under the square root sign we cannot have a negative number, so this quantity has to be positive or equal to 0, so that the function f of x is defined on the set of real numbers, right? So this is the first condition, right? So here we can take theta is equal to 2x minus 1. So we have here tan inverse theta should be greater than or equal to 0. So now consider this real number line. So here tan inverse theta has the range from minus pi by 2 to pi by 2, and between this interval, that is from minus pi by 2 to 0, we have all the negative numbers, and tan inverse theta cannot be a negative number, because here we have square root of a negative number, which results in a complex number, but here we are dealing with the set of real numbers, right? So here minus pi by 2 to 0, this interval has to be excluded, or we should discard it, because tan inverse theta cannot have values between minus pi by 2 and 0, right? So the acceptable values of tan inverse theta must lie from 0 to pi by 2, because here this interval contains all the positive numbers, right? So we have here a 0, and here we have pi by 2. So here we have closed, and here we have the open end, right? So here tan inverse theta has to be greater than or equal to 0. So if we merge these two aspects here, then tan inverse theta has to be greater than or equal to 0, but it should be less than pi by 2, right? And here we should remember that tan inverse theta here cannot take this value pi by 2, because here it becomes infinite, right? So we have now this inequality, right? So now we have to solve this inequality. So let us take a tan function of these three quantities. So here we have tan 0, and here we have tan of tan inverse theta, and here we have tan pi by 2. So tan 0 is 0, and here we know that from inverse trigonometric functions, tan inverse theta is equal to theta. So here we have theta, and here tan pi by 2. So tan pi by 2 is not defined, that is it tends to infinity. So here we have infinity, right? So let us now substitute the value of theta as 2x minus 1. So we have 0, here we have 2x minus 1, and here we have infinity, right? So now to solve this inequality for x, let us add 1 throughout this inequality. So here we have 0 plus 1, here we have 2x minus 1 plus 1, and here we have infinity plus 1, right? So here we have 1 simply, and here 1 and minus 1 and 1 get cancelled, and here infinity plus 1 is again infinity, right? So now let us divide throughout by 2. So dividing throughout by 2, here we have half, and here we have simply x. 2 and 2 get cancelled, and here when a large number, that is infinitely large number, is divided by 2, we again get infinity, right? So now here x belongs to this interval, that is half to infinity, because here x is equal to half is included. So the domain of this function is given by this interval, that is half to infinity. So this is how by using the concept of inverse trigonometric functions, we can easily find out the domain of functions of these kinds.